Welcome everybody, it's Mrs. Parsons here, and today we're talking about adding and subtracting with polynomials. So make sure you have your notebook out, ready to take notes. Some definitions that you might want to know is what is a polynomial? Well, a polynomial is an algebraic expression of one or more terms that are separated by addition or subtraction. So today we're going to be taking those polynomials and adding them or subtracting them. Polynomials also have a different number of terms. A term can be a number, a variable, or the product of a number and a variable. And we can classify polynomials by how many terms there are. For instance, you can have a monomial. That's a polynomial with just one term. So some examples are x, 7x, 7, 12y. All of those are monomials because they are one term. You could also have a binomial, bi meaning two, so it's a polynomial with two terms. So you have 3x plus 7, there's two terms there, or 8x cubed minus 9. That's two examples of binomials because they have two terms. So what's a polynomial with three terms? Well, that's a trinomial, tri meaning three. So an example is 8x to the fifth plus 12x minus 9. So there are three terms there. 1, 2, 3. Well, we will also be writing all of our polynomials in what's called standard form. So we start with the highest exponent and then go down all the way to the constant. Like terms, you guys have seen these before. That's something that has the same variable and the same exponent. And another review term for you is coefficient. That is the number in front of the variable. So in this example, we want to know if it's a polynomial or not a polynomial. Okay, a polynomial cannot have variables in the denominator. So if we wanted to circle the polynomials here, okay, 3x squared is a polynomial. 7x squared plus 11x is a polynomial. In fact, it is a binomial because it has the two terms. Okay, does this qualify as a polynomial? No, it doesn't. Why? Because there is a variable in the denominator. Now, this looks very similar. Is it a polynomial? Yes, it is. It's okay to have a variable in the numerator, but it's not okay to have one in the denominator. So how do we add or subtract them? There's a couple ways you can do it. You can vertically stack them and stack the like terms and add them or subtract them. But we normally see them done horizontally, where we're going to just look for like terms. And we have to remember, here's the biggest thing where everybody makes the common error. You have to distribute the subtraction sign when you have subtraction. And then we're going to put them in standard form. So looking at my first example, it's an addition problem. So we can just go ahead and start combining our like terms. If I have 6x and 7x, that gives me 13x. And if I have negative 9 and positive 12, that gives me positive 3. And this is in standard form already because we have the highest exponent. Even though it's an exponent of 1, it is still our highest exponent, all the way down to our constant. So let's look at another example here. If I have 12x squared plus 3x minus 10 plus 15x squared minus 3x plus 15, okay? To get this in standard form, I kind of cheat, and I just go ahead and start with the highest exponent here. So I'm going to do 12x squared and 15x squared. If I combine those together, I get 27x squared. Okay, so what's my next highest variable? That's my x's. So 3x minus 3x. Well, those add to 0, so those just cancel each other out. so I'm not going to worry about that. And then going down again, I have negative 10 plus 15 gives me plus 5. So that is my solution. Okay, one more example here. Okay, I start with my highest exponent, which is my squared. Do I have any like terms that go with it? Do we see any other x squareds? No, we do not. So we're just going to write 7x squared. Now I've got a negative 10x and a positive 5x. So combine those together and I get negative 5x. And then I have 12 and 9 to give me 21. Okay, so I've combined all my like terms. It's in standard form because it goes from 2, 1, none. So it's already written in standard form. Okay, subtraction is a little trickier because everybody forgets you have to distribute this negative sign through to the second polynomial. Okay, so we're going to go ahead and do that. The first one stays the same, 8x cubed minus 10x squared minus 12. But if I distribute this through, I get negative 12x cubed minus x squared plus 9. So essentially you're changing all the signs of the second polynomial. Now I'm going to combine my like terms. So starting with my highest, this should be a 3. Sorry about that. So I've got 8x cubed minus 12x cubed. So that gives me negative 4x cubed. Then go to my squareds. I have negative 10x squared minus x squared, which gives me negative 11x squared. And I have negative 12 plus 9, which gives me negative 3. Okay, check and make sure it's in standard form. 3, 2, none. Okay, I didn't have any just x's there, so that is my solution. Okay, my next one, still have to distribute that negative through to the second guy. So my first polynomial stays the same. My second one changes to negative 6x squared plus 8x plus 1. Now I can go through and combine my like terms, starting with my highest. So my highest is the x squared, and there is nothing to combine it with. So he just stays by himself. 7x and 8x gives me 15x, and then 3 plus 1 makes 4. Where's my mouse? Okay, last example. Looks a little difficult. Okay, remember you're going to distribute that negative through. So the first guy stays the same, 12a to the 5th minus 6a minus 10a cubed. Distribute the negative, I get negative 10a plus 2a to the 5th plus 14a to the 4th. So to cheat and kind of put this in standard form, we're going to start with our highest exponents, which is our a to the 5ths. So 12a to the 5th plus 2a to the 5th gives me 14a to the 5th. And then I have what comes next, a to the 4th. Okay, is there any more a to the 4ths? Looking, no. So he stays by himself, 14a to the 4th. And what's going to come next? A to the 3rd. So is there any more a to the 3rds? Nope. So he just gets written down here. Any a to the 2nds? Nope. Just a's. So I have negative 6a minus 10a, which gives me negative 16a. And I have combined all of my like terms.